Good morning, my students and viewers at home. You are all welcome to online teaching from St. Charles College, Onitsha. My name is Mrs. Anosike Josephine from Chemistry Department. My subject is chemistry, and the subject of discussion today is on salts. Specific objective of the lesson is that at the end of the lesson, you students should be able to 1. Define the term salts and give examples. 2. State different categories or groups of salts. 3. List different classes or types of salts. And finally, state some uses of salts. As you can see, we have 4 major areas to discuss. Now we go over to the first one, which is definition of salt. A salt is a compound formed when the replaceable hydrogen atoms of an acid has been completely or partially replaced by a metal or ammonium ion, NH4+. In a reaction between sodium hydroxide and hydrochloric acid, HCl, the resultant salt is sodium chloride. In this case, as you can see from the diagram, that only the sodium atom removed the hydrogen atom, one hydrogen atom, to form the salt. In this case, we call it complete replacement. All the hydrogen atom in the HCl has been replaced by the sodium metal. Another instance or another case is where you have a salt, an acid like H2SO4 reacting with sodium hydroxide. In this case, not all the hydrogen atoms in the acid has been replaced, only one, giving us the salt potassium tetraoxosulfate, that is KHSO4. In this particular instance, only one hydrogen atom was replaced, and we called it partial replacement. Salts can occur in different colors, and some of them are also colorless. As you will see in the diagram, the color salts are also used to recognize the type of metal that formed the salt. For instance, the salt that is blue in color, as you can see, it shows copper salts. Copper salts are most of the times blue. The one that is green is iron salts. And the other one is also, the one that is somehow yellow in color is also iron salt. But the type of oxidized oxygen in that particular salt is different from that of the green salt. The red salts are used to depict copper, but it is always the copper chlorides. Then the colorless salts, the very common ones are the high sodium chloride salts, as you can see. Sodium chloride salts are always colorless, or what you call white salts. Now we go over to the categories of salts. Salts are classified based on the type of acid that formed them. For instance, we have nitrate salts. These salts are formed from triazonitrate 5 acids. From the diagram, you can see various salts of nitrate, lead, potassium, sodium. All these have common NO3 that make them that group they belong, nitrates. The second group, the chlorides, they are formed from hydrochloric acid, HCl. And if you see the examples given to you, magnesium, zinc, sodium, they all have common Cl in their molecule, and that makes them to belong to the group of the chlorides. The next group are the sulfates. Sulfates are formed from tetraoxosulfate acid, H2SO4. We have the iron sulfate, zinc sulfate, manganese sulfate, copper 2 sulfate. They all belong to the same group because they have a common SO4 that make them to become sulfate salts. The last one are the carbonate salts. Carbonate salts are formed from triazocarbonate 4 acids, H2CO3. Here we have magnesium salt, magnesium carbonate, calcium, copper, and zinc. They all have common CO3, and that is why they are called carbonates. Now we are going to look into the classes of salts. Classes of salt. There are 6 main classes of salts. The first one is the normal salt, the one we call the normal salt. A normal salt is formed when there is complete neutralization between the acid and the base. In this case, you can see HCl, which is the acid, reacting with the base sodium hydroxide to give us sodium chloride, which is the salt, and then water. In this case, you can see that the sodium atom displaced hydrogen. There is no more hydrogen left in the reaction. So what we have is a normal salt. The second category or group is the second class. As you may see, we have the acid salts. An acid salt is formed when insufficient amount of the base is used to neutralize the acid. What do I mean by that? The quantity of the base used is quite small in quantity than the acid. It means that at the end of the reaction, more of the acid will still show itself in the salt. And that is why in the reaction between H2SO4 and sodium hydroxide, you have sodium hydrogen tetraoxosulfate 6, acid salt. That hydrogen there is the characteristic feature of acid salt. Anytime you see it, know it's an acid salt. Basic salts. Basic salts are formed when insufficient amount of the acid is used in the neutralization process, which means the base is more in quantity. Then what do you expect? You expect to have OH molecules in the salt, because OH is what we use to depict bases. So here you have the OH in the salt, zinc hydroxyl chloride. The next class are the ones we call the double salts. Double salts have two positively charged ions and one negatively charged ion. But what you have to know about this particular salt is that the positive ions are different, while the negative ions are the same. Like in potassium alum, you have potassium, which is the metal positive, aluminum, which is the metal positive. But the negative charge is SO4. So it depicts that two salts, potassium tetraoxosulfate 6 and aluminum salt, combined chemically to form the double salt, potassium alum. The next one is the complex salt. Complex salt is one that consists of a group charge of ions, like NH3O4. Now, in this case, you can see that 4 groups of that particular ions combined with copper, forming tetraamine copper 2 ion. They do that by what we call dative bonding. So in complex salts, we have groups that will undergo dative bonding with the metal. The last one are the hydrated salts. Hydrated salts are salts with water or crystallization in their molecule. That means that these salts have water in them, and sometimes they can be lost by heating or by simple exposure to the atmosphere. The salts that don't have water or crystallization are called anhydrous salts. We now come down to uses of salts. There are so many uses of salt, but for the purpose of this lesson, you have the following uses and the salts that are responsible for them. We have ammonium chloride. Ammonium chloride are those salts we use in charging batteries, dry cell batteries, like car batteries. You have ammonium chloride in form of solution or infused form. The second one, sodium chloride. Sodium chloride is very good in preserving food like fish. You can spread some quantity of sodium chloride on and leave it for some time. It will stay for a long time, for at least for 3 months before it decays. And then we use sodium chloride in glazing pottery, like in ceramic industries, where you have all those plates, cups, and so on. We use sodium chloride as one of the things we use, materials for producing them. We have calcium tetraoxosulfate 6. This one, you are very familiar with that, plaster of Paris. When you see people who have problem, joint bones or broken bones, we use it to amend or to help to set the bones right. Then you have the number 4, calcium trioxocarbonate 4. That one is used as medicine when you have something like stomach upset. In the market, we have what we call Andrews liver salt. Part of the content of that particular salt is calcium trioxocarbonate 4 and others like magnesium. they have to reduce the acidity of the stomach. The last one is calcium chloride. That one is very common in laboratory because we use it to dry salts prepared in the lab by putting them in the desiccator, and they now dry the salt after preparation. Now we have come to the end of the lesson. We would like to evaluate ourselves by answering the following questions. 1. Define the term salt and give 2 examples. 2. Give 2 examples of the following: normal salt, basic salt, acid salt, double salt. 3. Write the formula of the acid and the base that produce the following salts: KNO3, lead methanoate, zinc chloride, ammonium triisocarbonate 4. Now submit your assignment through my WhatsApp contact 08037413649 at St. Charles College, Onitsha. I repeat again, 08037413649. Thank you all for listening, and goodbye.